Hello guys, so let's do a quick review of the three formulas that we have seen so far. So the first one is velocity equals square root at force over rho. The highlight of this formula is going to be always to find rho. Rarely you're going to find a case scenario where I'm going to be asking for rho. So usually you have to find rho first, and rho equals mass over length. Another highlight of this formula are the units you're going to be using. Velocity is always meters per second. Force is always in newtons. Mass is going to be kilograms. Could be capital K or kg, and length is going to be always in meters. So this formula is very straightforward, where you just plug in the values and do the equations. Second formula is V equals 20.1 times square root of temperature. The highlight of this formula is the 20.1, which refers to atmospheric gases. And this is a standard number. So unless I'm asking you, in the case scenario, a question where, what is the speed of sound in a chamber full with hydrogen or oxygen or carbon monoxide, I'll give you this number. Other than that, if I don't specify a gas, then you have to assume by default, this is a question regarding atmospheric gases, and the constant value is going to be always 20.1. Now let's go with temperature. Temperature is always going to be measured in kelvins. And this is the tricky part. On the case scenario, we're always going to put the temperature in Celsius. So I can ask you, what is the speed of sound in a room that is at room temperature? Room temperature is always going to be 20 degrees Celsius. So what do? You grab this 20 and you're going to add it to 273. So the total is 293, and this is a number that is going to go up here. 293 kelvins. Some case scenarios, same thing, they're not going to tell you the temperature of the environment, but they're going to give you hints. For example, they can say, on this equation, the environment, the temperature, water freezes. So if they're talking about water freezing, then that will be 0 degrees Celsius. So you grab that 0 plus 273, and the answer is 273. And this is a number that is going to go over here. 273. Another hint or case scenario is an environment where water boils. Boiling water. And that's 100 degrees Celsius. So same thing, you grab that 100, add it to 273, and that is 373, and that's the number that is going to go over here. So again, just be careful with this formula. If I don't specify a specific temperature in Celsius, and I say room temperature, well, that's 20 degrees. Water's freezing, that's 0 degrees. Water's boiling, that's 100. Other than that, you're gonna find specific temperatures to add to 273. You add it, that number goes, you plug it over here, you do the square root times 20.1, and that's gonna be your answer for velocity. And the last formula that we mentioned last week was velocity equals lowercase f frequency times lambda. The highlight of this formula is usually it's not straightforward. I can ask for frequency, I can ask for lambda, and you need to know how to manipulate this formula in order to get the right formula into the equation. So if I want to know lambda, frequency is on the way, I need to get it away from there. So I need to identify first what is the equation between these two factors. So we see here the frequency is going to multiply lambda. So in order for me to move frequency away from lambda, it's going to do the opposite on this side. So it's multiplying, on this side it's going to go dividing. So it's going to be velocity divided by frequency, and that equals lambda. And you do your equation. Or it can be the other way around. I want to know the frequency. So same thing, I want frequency to be alone on this side, lambda's on the way. Main equation between those two is a multiplication. So in order to move lambda to the other side, it's going to do the opposite, and it's going to go from multiplying to dividing, where it's going to be velocity divided by lambda equals frequency. Okay, and those are the little tricks for those three formulas. If you have any questions, please don't hesitate to send me an email, or you can call me, make an appointment, and we can go in detail with those equations in my office. Okay, have a nice day.